Okay, this is day 2 of our this is the day 2 video of hyperbolas. We're just building on what we started the day before. So, what if you're only given vertices and foci? So I want us to look at graphically what's happening if you're given a vertice and a foci. Here's the equation of your hyperbola. Okay, this is if it's horizontally oriented. Okay, horizontally oriented. And what I mean by that is the center and the two vertices go along a horizontal axis. Okay, center and the two vertices go along the horizontal axis. Now remember, they will give you a vertice and they will give you foci. So think about where the foci are. Foci sit within the arch, so they're out here. Okay, so when you graph your vertice and your foci, they should all fall in a straight line. And that will tell you, is it horizontal or is it vertical? Because look at this vertical one. Here's the vertices. Here's the center. The foci sit inside the arches. Okay, look, they are all in one line, but this line is a vertical line. Now, notice how that changes the equation. If it's horizontal, the x squared is the first term of the equation. X squared over a squared. Okay, over a squared. If it's vertical, the y term is the first term in the equation, up and down. Okay, so you really do have to graph these points, get a feel for how is this oriented, because that'll tell you how your equation will be built. Okay, and remember the distance between the vertice and the center is that value of a. The distance between the foci and the center is the value of c. Once you know a and c, you can find b, and I'll review you in a minute. But this is what I want you to come back to this and remember, the orientation of the hyperbolas determine the equation, and vice versa. So make sure you catch that. If it's horizontal, x squared over a squared is the first term. If it's vertical, y squared over a squared is the first term. All right, let's try this. So here's some steps you're going to follow. All right. First, okay, I just wrote these equations here. Remember we talked about this. It's a squared plus b squared equals c squared. That's the relationship between a, b, and c with hyperbolas. And then here's your basic equation. X minus h squared, y minus k squared. A squared minus b squared equals 1. So remember all these components. So steps to take. First thing you're going to do is graph the vertices and the foci to determine the orientation of your graph. Find the center. The center is going to be the midpoint between either the foci or the vertices, not both. But you're going to just find the midpoint between them. Then you'll find C, the distance between the foci and the center. And then A will be the distance between the center and the vertices. Use a squared plus b squared equals c squared to find B. And then write your equation. That's all you have to do. Let's try this. All right? Solve this hyperbola given foci and vertices. So the first thing I want you to do is to graph this. Okay? So 1, 2, 3, 4, 5. That gives me what I need. Okay, so my foci are, here's -1, 2, and here's 5, 2. Vertices are at 0, 2, and 4, 2. Okay, so if I draw a straight line through this, what is it, horizontal or vertical? It's horizontal. So I know this is horizontal, so I know it's going to be x squared over a squared minus, y squared over b squared equals 1. I need to find the center. Remember, the center is the midpoint between either the foci or the vertices. Pick one, it doesn't matter. You're going to get the same value. I'm going to pick vertices just for the fun of it. Midpoint, you're just going to average the x values, average the y values. So 4 plus 0 is 4, divided by 2 is 2. 2 plus 2 is 4, divided by 2 is 2. So this is my center. Okay, so that's the first part of my answer here. My center is 2, 2. Right? So in my equation, I already know x minus 2 squared over minus y minus 2 squared equals 1. Now I need to figure out what is a and what is b. Now remember, a is the distance between the center, which is right here, the center and the vertices. So I need to figure out what is this distance right here between this and this. Well, if my vertice is at 0, 2, and my center is at 2, 2, what's changing? My y-coordinates stayed the same, my x-coordinates changed by 2. If I look from this point, the difference between 4 and 2 is also 2. That means that the a value is 2, because remember, a is the distance between the center and the vertice. Now, C is the distance between the center and the foci. All right, so I'm looking at this distance now. What is the difference between either end of this? It doesn't matter. From 5,2 to 2,2, what's changing? X coordinate's changing by 3, right? From the center, it has to move 3 spaces to the right, 3 spaces to the left to get to the foci. So the C is a 3. Now I'm going to use good old Pythagorean theorem to help me find what B is. If A squared is 4 plus B squared, C squared is 9, subtract 4, I get B squared is 5. That's all I need for this equation, okay? Look, it's A squared is under the X squared term. So if A is 2, A squared is 4. B we just discovered is the square root of 5, so B squared is 5. And C we discovered is 3. That's what you need to do to finish these problems. Figure A, B, C, the center, and then plug them into the equation correctly. So to finish this graph, okay, this is my center, this is my vertices. My foci have to come out like this. Sorry, my parabolas have to be arranged like that. Foci sit within them. Okay, so there's your hyperbola. Don't worry about co-vertices today. We're just looking for these elements. So my first foci is at 0, 0, foci, and at 0, 8. So here's another foci. My vertices sit at 0, 3, 1, 2, 3, and 0, 5. Well, okay, so hopefully you see that they all sit in a straight line, but it's vertical. So that tells me that my equation will be y minus k squared minus x minus h squared. A squared always sits in the front. So this is the format my equation will take. So I need to figure out, okay, what is my center? Well, what is the center point between all of these guys? Well, you can look at this and see. The center between the two vertices is this one right here, 0, 4. Okay, so 0, 4 is my center. So I already know part of my equation. So it would be y minus 4 squared minus x squared. Now, equals 1. A squared, remember, A is the distance between the center and the vertices. So what is this distance right here? Just 1. 1 squared is 1, so that's going to go down here. C is the distance between the center and the foci. So look at, if this is my center, look at your points. What's the difference here? It's changing by 4. The y value is changing by 4. So C is 4. So then if I write my equation, 1 plus b squared equals c squared, which is 16. So b squared is 15. So b then is the square root of 15. So I'm going to put 15 down here, and there's my equation. That is what it looks like. Now, if I wanted to graph this, it's vertically oriented. It's going to curve from the vertices. The foci sit inside the parabolas, remember? So without drawing the box of the asymptotes, that'll give you an idea of what the hyperbola looks like. You've got to have the foci, the vertices, and the center to gauge it. All right? Hopefully this makes sense, and you'll be ready to try some more examples when we get to class tomorrow. Right? Okay, for class, I want you to try this one on your own. It'll be our starting point for our discussion tomorrow. So please try to come prepared and bring any questions you might have.